Hey, so in this video we're going to be matching graphs, or basically analyzing graphs. So let's go ahead and get started. Alright, so we have 6 scenarios about a car moving in a parking lot, and we have A, B, C, D, E, F, 6 graphs to match with them. We're only going to use each graph one time, and we're going to cross them off as we go, so make sure you're paying attention. Number 1, a car speeding up when the stoplight turns green. All right, so we're using the phrase speeding up. Speeding up is the same thing as like increasing speed. Maybe it's going from 0, 5, 10, 15, 20. It's speeding up. All right, so what kind of graph do you think this goes with? All right, I'm hoping that your thought process is that it's some sort of curved line because the speed is changing. It's speeding up. So that means that it could either be graph D or graph E, right? These are the only two graphs that have curved lines. So we're talking about speeding up. That means we're going from slow to fast. So in previous videos, we've talked about how break the curved line down. So essentially, the first part of this curved line is very shallow, right? Then it gets fast. So we're going from slow to fast. That appears to be speeding up, right? Let's double check that E is not speeding up too. So for E, we have a steep line at first, then it gets shallow. So the steep, fast, shallow, slow. So we're going from fast to slow. Graph E is slowing down. So for number 1, the car speeding up, it's going to have to be graph D. So we're not going to use this again. Go ahead and cross this off. All right, number 2, we have a car parked in a parking lot. So if it's parked, that car is not moving. Think about which graph would match this scenario. Okay, so I'm hoping that you picked graph A. So graph A is the only one with this horizontal line, meaning the car is not changing distance for any amount of time. It's not moving. So graph A is going to be crossed out. All right, number 3, a car moving at a constant speed. So it's moving, but now at a constant speed. Constant speed, you should be thinking straight line toward the left side of the parking lot. All right, so we've been talking about right and left, north and south, up and down. So when we think about left, what kind of slope should you be thinking about? Right, it should be some sort of negative slope if we're talking about moving towards the left side of the parking lot. So left, negative. And it's also a constant speed, so it's some sort of straight line. So take a look at our graphs. Make a guess as to which graph matches this scenario. Okay, I'm hoping that you pick C. C is the only one with a negative slope. So C is our correct answer here. It has a nice straight line, and it is a negative slope. So C we can cross out. Number 4, a car is slowing down. So here, the speed is changing. It's decreasing. It's going from 20, 15, 10, 5, 0. It is slowing down in speed when the stoplight turns red. So here, we're talking about slowing down. What kind of line should we be looking for? Right, some sort of curved line. And we've already used graph D, so we're not going to be using that one. B is a straight line, F is a straight line. So obviously, by process of elimination, it has to be E, right? So let's double check. We said slowing down. In graph E, this first part has that steep part, right? The steep part means it's going fast. It gets shallow, so that means it's going slower. So here in E, it is actually slowing down. It starts off moving very fast, and then the car does end up slowing down. So number 4 is E. All right, number 5. A car moving slowly, at a constant speed toward the right side of the parking lot. So right side. All right, so if we're thinking slowly, that should be some sort of shallow line, right? Constant speed, notice how I did a straight line because constant speed. And then right side, notice how it was a positive slope because we're moving to the right. So go ahead and pick out which graph goes with number 5. Okay, right. Yeah, we only have 2 graphs, B and F. B has a slightly steeper slope than F. F is a much shallower slope. They both have a constant motion and they're both moving to the right, but F is the one that's moving slower. So number 5 is F. All right, and last but least, number 6, a car moving quickly at a constant speed to the right side of the parking lot. And yes, that does go with B. So we have successfully completed them all. All right, last practice. So now we're going to turn these distance time graphs that are provided up top and turn them into their speed versus time graph. So, top graph. We have a distance versus time graph, right? And notice that is this horizontal line. So what does that mean that the object's doing? Not moving, right? So if it's not moving, does that object have a speed? No, of course not. So that means that the speed is 0. So notice how the horizontal line is down here right above or right on the x-axis. That red line, kind of hard to see. But yeah, if an object's not moving, it could be anywhere on this distance versus time graph, anywhere. But always on the speed versus time graph, it's going to be right down here at the bottom on the x-axis. All right, next graph. Let's look at this distance versus time graph on top. So, what do you notice about the motion of this object? All right, so it's a straight line, so it is constant. What else do you notice? Look at the direction of the slope. It's a positive slope, right? So probably the object's moving to the right or forward or up, some sort of positive direction, right? So it's a constant speed, meaning it's not changing. Kind of an average speed. Maybe if the maximum is 20, maybe it's a 10 meters per second the whole time to the right. So on our speed graph, where would you draw your line? All right, so I'm hoping you said horizontal, and it could have been anywhere on this graph. All it has to be is a horizontal line because it's a constant speed. So a constant speed is always going to look like a horizontal line on our speed graph. All right, and technically speaking, if we're moving to the right, that's a positive direction. So these are all positive values. If our graph had looked down here and this was a negative value, our negative values would have been down here. So if the object was moving to the left, we could have drawn it somewhere down here that the object was moving to the left. All right, let's look at our third graph, distance versus time, and now we have a curved line. So what does that mean? Right, it means that the motion's not constant. Something is changing. So we look at this graph, it's shallow at first, then it gets steeper, so it's slow, then it gets fast. So what's the speed doing? It's increasing, right? It's getting faster and faster and faster. So the speed is changing, right? It's increasing. The speed is going from 0 to 5, 10, 15, 20. So down here on our speed versus time graph, how would you draw that? Increasing speed. All right, I'm hoping that you drew some sort of positive sloped line. And it should be a straight line because we're still talking about a constant acceleration. There's a pattern, 0, 5, 10, 15, 20. All right, let's look at our next graph, our last one for this video. So we have another curved line, except this time it's going from fast to slow. So if it's going from fast to slow, what's happening? Right, it's slowing down. It's decreasing in speed. So if it's decreasing in speed, that means it's starting at maybe 20 meters per second. Then it's going to 15, 10, 5, 0. All right, so your graph should look something like this. It should be a negative slope line. It should be a straight line. All right, that's it for this video. If you have any questions, leave a comment.